Welcome, everyone. I'm Electron Tom. I'm excited to see some people signing in. I'm going to give it just a few minutes because sometimes people do have to adjust their schedule a little bit to jump in, but I'm excited that you are joining me today, and we'll get started in just a second. I'm going to give it just a few minutes because sometimes... All right, so I'm also signed in on my laptop, so I'm going to welcome everyone. And so you can see I do have my spread of materials here, which I'll be talking about. A couple things about our session. It will be recorded, so if your phone gets disconnected or something happens, you have to step away. Don't worry, we will have it on our IGTV, ready for you to replay. But I see a lot of people coming in, and if you have a chance in the comments section, put where you're visiting from. So I'm Electron Tom, and I'm actually broadcasting from Miami, Florida. So let me know where you guys are joining from. East Coast, West Coast, international. We're excited to have you here. So in about one more minute, we're going to get started with our hands-on. We have Michigan. Well, welcome, Matt from Michigan. Thanks for joining today. We have some, I see NYC in the house. Yes, NYC, Michigan. Washington, D.C., thanks for coming, Megan. Brooklyn, D.C. I love it. Love it. So I am Electron Tom, and it's now 2 after. I'm going to wait about 30 more seconds, and we'll get started. If you have materials that are similar to what we had asked you to have, that's great. If not, you can once again go back and watch the replay of this to get your materials ready and try this at home. Santa Cruz, California, Bushwick, we got people from all over. So welcome. I'm Electron Tom. Woohoo! This is our first live streaming episode of Science from Amplify. I'm so excited to be with you today. We're going to have a lot of fun. So a couple things. I'm going to go over the materials. So what you're seeing in front of me right now, these are ring magnets. I have 2 of them. You can use other types of magnets. I'm using materials that came from one of our Amplify Science elementary programs called Balancing Forces. It's a curriculum, and I pulled these out of our kit, but a lot of these things you can find Amazon, obviously, Home Depot, Lowe's, those kind of stores have these, and they're really inexpensive if you don't have other magnets at home. I have some string here. Here's my paper clip that we're gonna get to float in the air. Some tape, it could be masking tape. You can have other types of tape as long as it's pretty durable. Some cardboard, and I'm sure you have cardboard laying around from all the deliveries from Amazon, etc. that you might have been getting. This is a solo cup. It's not a red solo cup, but it is a solo cup, and you can use any type of cup. And I want to point out one thing that I've got right here. This is not a flask. Incorrectly, a lot of people call these a flask. This is my Amplify Science Erlenmeyer flask, not a beaker. It's an Erlenmeyer flask is the full name of it. And lucky people out there, if you are really good at watching what I do and come up with an even more innovative design and prototype that you can send through our Instagram channel, or I'll even put my email address at the end, I might send you one of these. These are great to drink from. And obviously I'm not drinking any chemical things. So let's get started with the science behind what we're trying to do. So really, we're going to be talking about gravity. So gravity is what we call we have a couple different types of forces. It's all about forces. We're familiar with touching forces. So if I take this block and smash it into this one, those are touching forces, and they can push and they can pull, and we can do things with that. One force that's constant around us, gravity. Gravity's always going to pull things down, and that was loud, wasn't it? So gravity is pulling us down. So we're going to have to balance the force of gravity so this paperclip can float in the air. And to do that, we're going to use a magnet. So we have gravity, and we're going to counteract the force of gravity with a magnet. Now, a couple things about magnets. Let's review a little bit of science about magnets. Magnets have two properties. So just like I pushed and pulled these blocks, we have a push and pull with magnets. So I'm going to take my ring magnets and slide them on this pin. So if I put it this way, the magnets are attracted to each other. They are stuck together. So that is the word attract. That's the same as a pull with other forces. Now I'm going to jump into repel. And this is a really fun trick that you could try as well. If you have ring magnets, you can turn one over and notice it floats, it bounces. If I push it down, it comes back up. It is being repelled. So that's what we call a non-touching force. When I push the blocks around, that was a touching force. This is a non-touching force. And you're going to see that maybe we can use this magnetic force to counteract the downward force of gravity. So if gravity's pulling us down, we want the magnets to pull that paper clip up. So how are we going to do this? Now, we're getting into what's called an engineering challenge. And so the goal of engineering is to design and build things. So I have the materials to design what I want to design, and I'm going to build it. Now, my prototype is going to be awesome, but I bet you can come up with even more different types of prototypes that could be amazing. And so you can use other materials that you have around the house to even build more interesting ways to make this paperclip float. So the first thing I want to do is I'm going to take some string. I'm going to take, about that much. It doesn't have to be extremely long. I do have a ruler here. Some of you might be more precise, so maybe you can go 30 centimeters, which is a foot. I want to go with centimeters. We are scientists. Electron Tom here is not going to talk in imperial inches. So we're going to cut the string, and I'm going to just tie it to the paperclip. So make a simple, quick, easy knot. It is tied. A key point that what I want to do right now, make sure it's a really tight knot. I want to cut off this extra that's hanging down. That extra provides more mass that's pulling down with gravity, which is going to make it harder on my magnetic force. So I'm going to trim that as close to the knot as I can. So now I have my paperclip. It is not floating. My goal is to get it to float by these magnets. Notice how it's pulling it, and it wants to go with me. So if I pull it up, it's touching. It's not floating. I want to get it to where it can float in the air like that. Kind of cool, right? It's not magic. It's science, but we can talk like magic because Halloween's coming, right? So now with our other materials, I've got 2 pieces of cardboard. You can go smaller. I wouldn't go much smaller than this, but you can definitely go larger if you want. And if I'm looking at the centimeters on this, this is 18, so you can go anywhere 18 to 30 centimeters, just long enough so it can fit underneath your cup. So the first thing I'm going to do is build my base. So this piece of cardboard is going to be my base, and I really want to secure my cup to the base really well. So I got a really long piece of tape. I'm going to take it over the solo cup. Let me just pick this up, and I'm going to bring it underneath so my tape goes underneath the cup. There we go. Got a little twisted. No problem. I'm going to put another piece. I'm going to take it down the back side of the cup. So I'm really making sure, I got to go a little bit longer. I'm really making sure my cup is attached to the base. This is going to provide the foundation for my floating paperclip. So there's my foundation. Now, there's a couple things. You're going to want to make a slit in your cardboard. So take some scissors, and right here in the cardboard, you're going to make a cut. I'm going to make 1 scissor length. You can see there is a flap. All right? That is important because I'm now going to take my string and feed through that cut that I just made. All right. So now you can see if I have it upside down, then I can even pull my paper clip up or down by pulling up or down on the string, and that allows me to then move my paper clip in either direction. So now I have my base all set. My other cardboard becomes the roof of this structure. Now, once again, this is my prototype. You can design the exact same prototype, and it's really cool, but then I want you to think, redesign. That's what engineers do. They don't, they have a problem, they want to make it better. Optimal design is what we're going for. So I'm going to stick this on top, but I'm also going to tape it in place. We want to make sure that it doesn't fall, so it looks like kind of like a shelf here. I'm going to put a little more on the back side. So hopefully you're following along with me. So what I'm trying to do is create a structure that can allow the magnets to sit up here to pull this paperclip up against the downward force of gravity. So with that, I'm going to take my two magnets, I'm going to separate them, and I'm going to stack them right here on my lid, on my top shelf. And now I'm going to attach the paperclip. Watch as I pull the string from the bottom, a little further, and now I have a structure with a floating paperclip. I can put my pen right through there. Not magic, it's science from Electron Tom. And so you can see my paperclip is now balanced. Oh, it just became unbalanced. So when we talk about forces, when forces are balanced, such as gravity and magnetic force in this case, then the object should remain pretty still. It's not going to fall. But if they become unbalanced is when they fall. So if I pull it a little bit further, that's when it became unbalanced. Now, we know that when you are working with science investigations, that data collection is super important. You can't just say, oh, it worked. You need data to back it up. You need that critical set of data. So how can you collect data on this? One thing I can recommend is taking your ruler and making marks on your string. I would suggest not just centimeters, maybe even the millimeters, those little tiny marks in there. And you can make the marks on your string, connect it to the magnet where it's touching, and then incrementally pull each little line on your string until it collapses. And then write that down. Write down your findings. And in science, do we want to just do one trial? I don't think so. We want to do multiple trials. You can do this 10, 15 times and get a good average of how far that could pull down. Then you can think about the modifications you want to make. One cool modification I can make, I got a lot more magnets. Maybe if I put more magnets, that'll increase the force, and I could try it out that way. I could pull it down even further. And notice it's going even further because there's more magnetic force. That magnetic field got extended. You can do all sorts of cool modifications with things that you might have around your house. And so that's been my 10 minutes of fun with you guys. So keep in mind, there will be a quiz coming. So hopefully you paid attention. There'll be a pop quiz that you can answer after we sign off. And I'm gonna go ahead and put my email in the chat. If you send me a cool picture or post it on our Instagram feed of your structure, even if you build it 2 days from now, 3 days from now, I want to see it. The weekend is a great time, a rainy day, to build a really cool device. I'll send you one of these guys. You can drink your lemonade from it and have a great time. So I'm going to put my email address in to the chat. And if there's any questions, let me know. I saw that people wrote that it's floating, that it's awesome. So this is the first of many of our exciting, my Electron Tom and friends. Sometimes I may have some friends join, and they may bring a different perspective. You know, I have a friend, Lauren, who's a great female scientist. Remember, science can be done by anybody. And Amplify Science is here to bring science alive for you, teachers, students, and families. So thanks again. I'm Electron Tom, and I hope to see you next time on Instagram Live. Bye-bye. I'm signing off.